And last but not least, we're going to look at equations of roses in polar form. Now, to me, these are definitely the coolest equations and graphs that we're going to talk about. So let's just jump right in. All right, so when we have equations that look like this, r equals a sine 2 theta, or r equals a sine 4 theta, or a sine 3 theta, or a sine 5 theta, I think you get the picture here. Anytime we have a sine of a multiple angle, so 2 theta, 3 theta, 4 theta, 5 theta, 6 theta, whatever it may be, those equations will always graph roses. Now, they're called roses, but to me, they really look more like daisies. I mean, as you can see there, these look like daisy petals more so than rose petals. But, they didn't ask me when they named it, so it is what it is. And also, I think it goes without saying that we could also see a cosine 2 theta, or a cosine 4 theta, or a cosine 3 theta, or a cosine 5 theta. So these can take the form of a sine of a multiple angle of theta, or a cosine of a multiple angle of theta. Now, the first thing we need to know about these equations is we need to look at a. The number a, or the coefficient of the trig function itself, will always tell us the length of a petal. So in this example here, our a is 3. So the length of a petal is 1, 2, 3 units. And so each petal will be 3 units long. Same thing goes for this example here. A is 3 again. That just tells us the length of each petal. 3 is the length of each petal. 3 is the length of each petal. So the A in these equations will always give us the length of each petal. The second thing we need to take note of is the coefficient of theta itself. So in this case, we have a 2 theta. And in this case, we have a 4 theta. If the coefficient of theta is even, we will always see twice that number of petals on our graph. So here the coefficient was 2. That's an even number, so we should expect to see twice as many petals. And we do. There's 4. Here the coefficient is 4. 4 is an even number, so we should expect to see 8 petals on our graph, and we do. We have 4 above the x-axis and 4 below the x-axis. Now, if the coefficient of theta is odd, as in here and here, then we only expect to see that number of petals on our rows. So in this example, the coefficient of theta is 3. That's odd. So we see 3 petals on our graph. In this example here, 5 is the coefficient of theta. 5 is odd, so we expect to see 5 petals. Well, when we look at these graphs, you think, well, that's kind of neat, but it could also be confusing, like if I'm asking you to graph a certain type of rose. How do I know where to situate the petals? How many petals go above the x-axis? How many go below? How are they spaced? Like, how do we orient the roses on the graph? And that would be a great question. And that's exactly where things can get a little bit tricky when graphing these roses. So when we're graphing roses, how do we space the petals? Like, how do we know the orientation of the petals on the graph? All right. So for even theta sine roses, even theta sine roses. So this will be like sine 2 theta, sine 4 theta, sine 6 theta, and so on. The petals will be evenly spaced around the plane, and there will be no petals on an axis. So in other words, the number of petals in each quadrant have to be evenly dispersed in each quadrant. No petals can lie on an axis, whether that be the x-axis or the y-axis. All of the petals have to be evenly distributed in each of the quadrants. For odd theta sine roses, so this would be like sine 3 theta, sine 5 theta, sine 7 theta, and so on. There will always be one more petal above the x-axis than below it. So if I'm working with a sine of 3 theta, I would have 2 petals above the x-axis, 1 petal below the x-axis. If I'm working with sine 5 theta, I would have 3 petals above, 2 below. Sine 7 theta, I would have 4 petals above, 3 below. And the hemisphere with the odd number of petals will have 1 petal on the y-axis. So again, if I have sine of 3 theta, I know I'm going to have 2 petals above the x-axis, 1 petal below. 1 is an odd number. That's below the x-axis, so that 1 petal has to lie on the negative y-axis. In the case of sine of 5 theta, I know I'm going to have 3 petals above, 2 below. 3 is the odd number. That's the number of petals above the x-axis. So I know that middle petal has to be lying on the positive y-axis. And the other petals have to be evenly dispersed around that one. Now let's talk about even theta cosine roses. So this would be like cosine 2 theta, cosine 4 theta, cosine 6 theta, and so on. Those petals have to be evenly spaced around the graph, but the first 4 petals we're going to graph will be lying on the positive x and y axes and the negative x and y axes. So the first 4 petals that we're going to graph will be 1 on the positive x-axis, 1 on the positive y-axis, 1 on the negative x-axis, and 1 on the negative y-axis. And then the remaining petals have to be evenly dispersed between those 4 petals. Now when it comes to odd theta cosine roses, so like cosine 3 theta, 5 theta, 7 theta, and so on, we will evenly space those petals, but the first petal we're going to place will be on the positive x-axis. This shouldn't say evenly spaced roses. By the way, that should say evenly spaced petals. Please forgive the error. Okay, so for odd theta cosine roses, the first petal we're going to place is going to be a petal on the positive x-axis. Once we place that petal, we're going to evenly space the remaining ones around the rest of the plane. Put the first one on the positive x-axis and evenly space the other ones around the plane.